Hi there, it's Mr. Graham, and in this video we're going to look at how we find the highest common factor through a process called prime factorization. Now before you watch this video, make sure you've watched the videos on the Year 5 mathematics page. There's a video there on factors, there's a video there on prime factors, and there's a video also on highest common factor. Make sure you've watched those sister videos first. Okay, on the screen we've got two numbers. We've got 100 and on the right hand side 140. We want to find the highest common factor of 100 and 140, and we're going to do it through this process called prime factorization. So to begin with, we are going to find the prime factors of each number, and we're going to start with 100 obviously. So we're looking for any times table that gives us an answer of 100. A nice easy one that springs to mind, 10 times 10. Now we're going to look at each of those. Values in turn. So 10, is it a prime number? No. So we need to break it down. 2 times 5 makes 10. Let's look at each of those in turn. Is 2 a prime number? Yes, it is. So we'll circle it. We're finished with that one. Is 5 a prime number? Yes, it is. So we'll circle it. We're finished with that number. Okay, so we're finished with this 10 because we broke it down into 2 multiplied by 5, and they're both prime numbers. We're going to go back up to this 10 that we've not tackled yet. We're going to do exactly the same thing. So we're going to partition it, and we're going to have 2 times 5 again, because the product of 2 times 5 is 10. And we all already know, because we've just done it a second ago, that 2 is a prime number and that 5 is a prime number. So we're left now with the prime factors of 100. Now I'm not going to put them into a list in ascending order like I normally would do. I'm going to leave them for a second, and I'm going to go across now and work on 140. So moving across to 140 then, we're looking for any times table that gives us an answer of 140. Okay, I know that it is an even number, therefore it is in the 2 times tables, but better than that, obviously because it ends in a 0, I know straight away without even thinking about it that it's a multiple of 10. How many 10s make 140? It is, of course, 14. Now, is 10 a prime number? No, it is not. So we're going to partition it again. We're going to find a times table that has a product of 10. And like the previous examples, it's 2 times 5, which has a product of 10. Is 2 a prime number? Yes, it is. I'll circle it because I'm finished with it. Is 5 a prime number? Yes, it is. I'm finished with it. Let's go up to the 14. Is 14 a prime number? It's an even number. It can't be a prime number. The only even number that is a prime number is 2. So let's find a times table that has a product of 14. 2 times 7 is 14. Let's look at each of those in turn. Is 2 a prime number? Yes, it is. We'll circle it. We know we're finished with that one. Is 7 a prime number? Yes, it is. We'll circle it. We are finished with that one. So there on the screen at the minute, we've got the prime factors, the green arrow showing them now, the prime factors of 100. And then on the right hand side, the green arrow is showing the prime factors of 140. I'm just going to shrink the screen now to do the next part. Okay, now underneath each number, I'm going to list the prime factors in ascending order. So in other words, from smallest to biggest. So I've got a 2, I've got another 2, I've got a 5, and I've got another 5. Okay, all the prime factors of 100 have been listed in ascending order. Let's do the same for 140 in ascending order. We've got 2, we've got another 2. We've got a 5. And we've got a 7. And we've now listed the prime factors of each number. Now, to find the highest common factor, we're now going to compare the prime factors of each number. Let's look at the prime factors of 100 first of all. We've got 2, 2, 5 and 5. We're going to take each of those in turn and see if they've got a matching number on the other side. So let's look at the first one. We've got 2. Do we have a 2 here? Yes, we do. We're going to cross them both out. We're going to put it in the middle. Let's look at the next number. We've got a 2. Do we have a 2 here? Yes, we do. I'm going to cross them both out, and I'm also going to put that in the middle. Let's look at the next number. 5. Do we have a 5? Do we have a 5 on the other side? Yes, we do. I'm going to cross them both out, put the 5 in the middle. And the final example, we've got 5 and a 7. They don't match, so there's nothing we can do with them. Now, the highest common factor of 100 and 140 is now staring us in the face. If we do this calculation that I'm putting a circle around, that will give us the highest common factor. So 2 times 2 is 4, and multiply that by 5, we get 20. So the highest common factor of 100 and 140 is 20. Now, that might seem a little bit long-winded, and in this instance you might have a point because 100 and 140 are quite easy numbers to work with. In the next example, we're going to work with larger, more awkward numbers to see how this process of finding the highest common factor through prime factorization is really useful. So let's look at another example. Okay, so we've got a new question on the screen now. We need to find the highest common factor of 154, and on the right hand side 1365. You can see straight away that this is a much more difficult question. We're up into the hundreds on the left hand side, we're into the thousands on the right hand side. So this is where the value of finding the highest common factor using prime factorization really comes into its own. Excuse me. So we'll start on the left hand side then. 154. Which times tables is 154 in? Well, it's an even number, so I know straight away that it's a multiple of 2. How do we find out how many 2's are in 154? We're simply going to half 154. Half of 150 is 75. Half of 4 is 2. 75 and 2, 77. Let's look at each of those in turn. So we've got 2. Is it a prime number? Yes, it is. Let's circle it. We're done. 77. Is it a prime number? No, it's not. So we need a times table that has a product of 77. I know that it's in the 7 times tables. 7 multiplied by 11. Let's look at each of those in turn. Is 7 a prime number? Yes, it is. Is 11 a prime number? Yes, it is. So we've now finished. We've found the prime factors of 154. Over on the right hand side here, we've got a much more difficult task. 1365. Excuse me. Okay. Because it ends in a 5, I know it's a multiple of 5. It's in the 5 times tables. So let's start building up that knowledge. I know that 5 2's are 10. I know that 5 20's are 100. I know that 5 200's are 1,000. So we're going to keep that 200 in my head. I'm just keeping 200 in my head. How many 5's are in this 300? Well, if there's 20 in 100, in 300 there's 60. So far I've got 265's. Now let's look at the last 2 digits. We've got 65. How many 5's are in 65? There are 13 5's in 65. So, how many 5s altogether? Well, we had the 200s, and then we had the 60, and then we had the 13. 205s made 1,000, 65s made 300, and 13 5s made 65s. Add them all together, the 200, the 60, and the 13 gave us 273 5s. Okay, now let's look at each of those numbers in turn. Is 5 a prime number? Yes, it is. We're done with that. Is 273 a prime number? Now, we may not know our prime numbers up to 273. We wouldn't necessarily expect you to know them, but we're going to use a simple piece of trivia to work this out. I'm going to, well, know straight away it's not a multiple of 10 and it's not a multiple of 5. But I'm going to check if it's in the 3s. I'm going to add the digits. The sum of the digits, we've got a 2 and a 7, which makes 9. And 9 and 3 makes 12. So it's in the 3 times tables because the sum of its digits, 12, is in the 3 times tables. So 273 is a multiple of 3. Now let's work back. I know that 3 100s make 300s. This is obviously less than 300, so it's less than 100. How much less than 300 is it? Well, it's 27. It's 27 less than 300. Now, 27 divided by 3 is 9. So what is 9 less than 100s? Because 3 100s make 300s. And this is 9 lots of 3, 9 groups of 3 less. So 100 take away 9 gives me 91. So 3 91s make 273. I'm going to double check that. 3 90s, 270, 3 1s, 3. That's correct. Let's look at each of those digits in turn. Is 3 a prime number? Yes, it is. Fantastic. Is 91 a prime number? No, it's not. 91 is a multiple of 7, and it's 7 times 13. Let's look at each of those numbers in turn. Is 7 a prime number? Absolutely it is. Let's circle it. We're done. And is 13 a prime number? Yes, it is. So we can circle it. We are done. We have found the prime factors of 1,365. There they are, circled in black. Now I'm just going to shrink the screen like in the previous example. In fact, there it is on screen, the previous example. Let's shrink the screen. And we're going to list the prime factors of each number underneath in red, like we did last time. So we have a 2 here, we have a 7 here, and we have 11 here. That's all the prime factors of 154 listed underneath. Let's now list the prime factors of 1,365. I'm looking for the smallest first, which is the 3. I'm looking for the next smallest, which is the 5, then the 7, then the 13. Now, to find the highest common factor, we're going to compare them and see what we've got. Let's start with on the left-hand side. We've got a 2 here. Have we got a 2 there? No, we don't. We don't. So it's no good. Get rid of it. We have a 7 here. Do we have a 7 here? Yes, we do. So we've got a 7. On this side, we've got 11 here. Oops, wrong button. We've got 11 here, but we've got no 11 here, so we can get rid of it. It's no good. On the right-hand side, we know there's not a 3, because we've finished all the prime factors of 154. We know there's not a 5, and we know there's not a 13. In the middle, we're left with just 7. Now, because there's just 7, we've got nothing to multiply it by. Therefore, the highest common factor of 154 and 1,365 is just boring old 7. Let's look at one final example. Okay, a final example then. On the left, we've got 975. And on the right, we've got 550. Let's start on the left as we have been doing. Okay, 975 ends in a 5. It's clearly a multiple of 5. However, I've noticed that the last two digits are 75. 75 is a multiple of 25. And I know that 900, because it ends in two zeros, is also a multiple of 25. So I know that this is in the 25 times tables. How many 25s go into 975? Well, I'm going to ask myself, how many 25s are there in 100? There are 4 25s in 100. So if there are 4 25s in 100, how many 25s are in 900? 9 times 4, 36. 36. Keep 36 in my head. I've also got, however, this 75, and this 75 is another 3 multiples, another 3 lots of, another 3 groups of 25. So we've got 36 groups of 25 that make 900, and another 3 groups of 25 that make the 75. So 36 add 3 is 39. Let's look at each of those numbers in turn. 25, is it a prime number? No, it is not. Let's break it down. 5 times 5. 5 is a prime number. Circle it. 5 is a prime number. Circle it. We're done with that arm, that leg. Let's move on. 39, is it a prime number? It is not. It's a multiple of 3, and it's 3 times 13. Is 3 a prime number? Absolutely. Is 13 a prime number? Absolutely. We've found all the prime factors of 975. Let's move across to 550. Now, it ends in a 0, which means it's a multiple of 10. However, the last two digits I've noticed are 50. That means it's a multiple of 50. And I know that 500 is a multiple of 50. So therefore, I know that this number is a multiple of 50. How many 50s make 550? Well, 10 50s are 500, so 11 50s make 550. Is 50 a prime number? No. Let's sort that one out first. What shall we do? Well, we know it's in the 10 times tables. 10 5s. Is 10 a prime number? No, it's not. Let's break it down. It's a product of 5 and 2. Is 5 a prime number? Yes, it is. Is 2 a prime number? Yes, it is. Let's sort out this 5 now. Is 5 a prime number? Yes, it is. Over to the 11 now. Oops, wrong button. Is 11 a prime number? There's the 11 there, sorry. Is 11 a prime number? Yes, it is. We've now found the prime factors of 550. Let's shrink the screen. And now let's list the prime factors of each number underneath in red. So 975 in ascending order, smallest to biggest. We've got 3, then 5, then 5, then 13. 550 then. Prime factors, starting with the smallest, we've got 2, we've got 5, we've got 5, we've got 11, and there we are, done. Now the highest common factor we're going to put in the middle, and we're going to look down both sides to see which numbers match. On the left hand side we've got a 3 here, but no 3 on this side, no good. We've got a 5 here, we've got a 5 here. Result, put it in the middle. We're done with those two. We've got a 5 here and another 5 here. Let's put that in the middle. We're done with that, we're done with that. We've got a 13 here, no 13 there. So we're done with that, which means we are done. So in the circle in the middle, the highest common factor of 975 and 550 is 5 multiplied by 5. 5 5s, 25, which is our highest common factor.